Hey guys, this is Mr. Hopkins' class. As you can see, he does not teach at all. How?
Te va a regañar.
Okay, let me try to show you. Que se vaya cayendo. I zoomed in. It looks better like that. I do not know how to use this. Just kidding. JK LOL. This is what he's doing. We're gonna make you go viral.
Okay, so yesterday was Monday, and I forgot to record Bianca, but basically, I just did those problems. Pause it right there, write those down. Okay, then, here are the answers to all of them. If you pause it real quick, you can see them. Okay, so then, I didn't really teach it, it was just like, here, do these problems. But there were some that were hard, so I'm going to go over them right now.
Hopkins, you're my hero.
Thank you.
Wait, is that the problem or the answer?
That's the problem. What do you got to do first?
Just take out what they have in common. No.
Factor everything.
Yeah.
Can't factor that, can't factor that, can't factor that, can't factor that, can't factor that. Oh, but I can factor that. What do you do that?
Take out.
With an x. That leaves x squared plus 1. Everything is now factored. Get the common denominator. So in this case, what would our denominator be?
Wait, you have to factor that. No, take it.
You can, it's x squared plus 1.
Yeah, it's
Not factorable.
okay.
So, what's our denominator going to be?
X. Wait, what? Isn't it just gonna be the last chunk?
It's that, yeah. Does that, you have to include one of each thing basically. It's like, oh, I need an x, I need an x squared plus 1. That already has both of them. So that's just my denominator. Okay, so then we go do the tops now. This one got multiplied by x squared plus 1, right? On the bottom. So multiplied by x squared plus 1 on top. Remember it's negative though. It's negative 1 times x squared plus 1. And you go to the middle one. Plus, what is it? 2x. Yeah, because that one got multiplied by x. Plus just 1. Because that already had the whole denominator, so it doesn't need anything. So then all you got to do, distribute the negative, combine like terms. So you'd have negative x squared minus 1 plus 2x plus 1. I think all you have is negative 1 and 1.
So negative x squared plus 2.
So negative x squared plus 2x. I didn't write the bottom. Oh, you can go further though. If this is factorable, you should factor it. Is it factorable?
Yeah.
Yes. Can't you pull out an x? What would that leave?
X plus
Negative x plus 2. So what happens here?
The x's.
The x's are gone. So I got negative x plus 2 over x squared plus 1. Need 62 also? Mm-hmm.
Just do all the 60.
Just do all the 60s?
Yeah.
Potatoes. first. Huh?
Factor.
Factor.
But yeah, factor for.
And again, there's only one thing that's factorable.
Which is the x squared minus 1.
This is pretty similar to the last one.
Yeah.
So what's the common denominator?
X minus
Yeah.
yeah.
Because that already has that. Just one of each. You handle it from there? Should just be 2 times x minus 1 plus 2 times x plus 1 plus 1. Combine like terms, simplify, factor if you can. What's that? 0, so it's 4x plus 1. That's it. That one looks down. This is where it got ugly. Oops, it's minus. What do we do with things that have negative exponents?
Bring them down.
Mm-hmm. So this becomes that. Right? What's this going to become?
1 over x squared plus 1, 2.
That is correct. Is there anything to factor? Nope. So what would your common denominator be?
X squared plus
Huh?
X squared plus 1 to the
Yeah.
4th and x squared plus 1.
Nope.
Something like that? Well, because there's 4 and then there's 5, so. Because they're the same thing except for it has an exponent of 4 and it has an exponent of 5.
This has 5 of these, this has 4 of these.
Yeah, so,
So you need 5 of them down here. That's it.
Why?
that doesn't make sense.
Let's say you had 32 and 16. What would you use? 32. Isn't 32 2 times 2 times 2 times 2 times 2, or 2 to the 5th? And 2 to, this is 2 times 2 times 2 times 2, which is 2 to the 4th.
Oh.
This is just times that, times this one by another 2, and I get this one, so that's my common denominator. Times this one by another x squared plus 1, and I get this one, so all I need is that. So if you have repeated factors, you just need the highest power of them.
Okay.
So like this is 5 of these, this has 4 of these, just use the biggest one. So then the top of this one just stays the same. And this is going to get multiplied by x squared plus 1. Does that make sense?
Yes.
And then you just have x squared minus x squared minus 1 over that thing. So you get negative 1 over that thing. Think you can do 64 now? Probably.
You can try it.
Try real quick. I don't need to see this. we left you guys out of the answer on 64, if you noticed. You have to do that one on your own. Now we're going to do newer stuff. Compound fractions. These are exciting. Just simplifying stuff. Later we'll turn them into equations, but right now we're just going to simplify. It's going to look crazy at first. Once you break it down, it's not bad. That's it. Any ideas of what do you think we're going to do? No idea, Tyler? Nothing?
Flip them.
Why? Flip? There's nothing to flip. Like, you can't flip. Later we will. Long story short, ignore that, simplify the top. Ignore that, simplify the bottom. Then we'll see what happens. So, if we're going to simplify that top, what are we going to do? Get a common denominator. And what would the common denominator be? But 3 doesn't have a denominator.
Yeah, it does.
Okay. Good. So yeah, it would just be x. So then on top you would have 2 minus 3x. Good. That's that one. Bottom, do the same thing. What's the bottom?
Is it 1 minus x minus 1?
So you got x minus 1 as your denominator. So this one on top is multiplied by x minus 1 minus 1. So really it's, what's this?
X minus 1.
X minus 2.
But can't you just cancel out x minus 1 and x minus 1?
No.
Why not?
There's that negative.
Oh, just kidding.
Is that true?
No.
Because adding and subtracting, you can't cancel stuff out like that. If it's multiplication, you can. Because of that minus, because that's subtraction right there, you can't take those away. If that was in parentheses and it was multiplied, then yeah, you could. Okay, now that we've got that down to a single fraction and that's down to a single fraction,
Flip them.
well, close. Leave the first one, change it to multiply, flip the second. So you're going to go 2 minus 3x over x times, flip that one, x minus 1 over x minus 2. That's a lame problem, man. Nothing's even gonna... Whatever. We don't need to worry about doing all this distributive property crap. Let's just... Done. A lot of times there will be stuff that cancels out at that point. This problem just decided that that's it. Yeah, like Yeah, same thing on all of them, pretty much that you're gonna get today. You just simplify the top, simplify the bottom, get them down to one fraction, flip and multiply. But then a lot, like I'm saying, a lot of times you'll have stuff that's gonna cancel out. This one just didn't, so whatever. And one more example. What was the other one I was gonna do? Oh, okay. This is. That one's a little crazier. There's two ways of doing this. Probably three, now like more than that. There's several ways of doing this. You probably just want the easiest one, huh? Well, I don't know. You tell me what's the easiest way then. You cannot bring that to the bottom. Because of that. But if you wanted to, you would have to break this apart first. Do you see how that is the same as that? Because look at, they already have a common denominator, and if I add them together, I just add the top. So all I did was just, I went backwards a step basically first, and said, okay, I have this all written over this, but I'm going to break it apart and write. Basically, I'm going to divide each term on top by the denominator. Right? It's like, you know, if you had like 2x plus 8 over 4, you could rewrite that as 2x over 4 plus 8 over 4. Right? We do that all the time. This just looks a little crazier. Now that you've broken it apart, sure, you can move that down. Okay? So let's do that. Maybe this will be the easiest way. So we'll have 4 minus x squared. We're not going to change that one right now. If you bring that down, what's going to be on the bottom now?
Four minus x squared times 4 minus x squared to the negative 1/2.
Okay, I'm writing it over here because, not because you're wrong, because what do we get when we actually multiply those? It doesn't start with 16. Notice how they're the exact same thing? So if you're multiplying the exact same thing with just different exponents, what do you do with the exponents? Add them. So now you just have 4 minus x squared to the 3/2 power. Okay. Guess what we're going to do now? I'm not going to move on until you guys guess it. Huh? What are we going to distribute? The what?
Yeah, can't you cross out top and the bottom?
This?
Yeah, so you get like 2, 2. Oh, never mind.
Oh, you could. Oh,
Like,
okay. You could.
like minus like what was that cost thing?
That's to the first. You could make it 1 over 4 minus x squared to the 1/2.
Right?
You want to do that?
Then
We could. It's not going to matter on this problem.
So what would we do next?
You tell me.
Find common denominator?
Yeah. Get a common denominator so you can add them back together. What would our common denominator be between these?
The second one?
this one, the bigger one,
Yeah,
right?
yeah.
Just like the last 63 and 64, they had the same thing except different powers. Just take the bigger power. So our common denominator would be 4 minus x squared to the 3/2 power.
You have to multiply everything else on top the same way.
So
No, but then it would just be that first chunk with the bottom
Wait,
one.
no, wouldn't it be 4 minus x squared to the second part?
what did the bottom of this one get multiplied by to create this?
The other.
3, 2.
4 minus x squared to the 1/2 power. Right? If I take that and multiply, look at it, it's right here. If I multiply those, I get that, right?
Yeah.
So that one is missing. So basically now on the top of this one, I'll write it all out. You'd have 4 minus x squared to the 1/2, that's that, times 4 minus x squared to the 1/2. That it needs to, that's the extra part from getting the common denominator. No, down? Okay.
Yes. And then the x squared stays x squared, right?
The common denominator on this one was x plus 1, x minus 1. That already had x plus 1, so I had to multiply the top, the bottom by x minus 1, so I multiply the top by x minus 1. On this one on the bottom, to get this, I have to multiply by 4 minus x squared to the 1/2, so I have to multiply the top by 4 minus x squared to the 1/2. Plus x squared. This already had the whole thing. Well, what's 4 minus x squared to the 1/2 times 4 minus x squared to the 1/2? 4 minus x squared. Plus x squared over that thing. Sometimes I'm lazy in my intermediate steps, so I'm just like when I'm just working on the numerator, I'll just like go, like, you can write it all out if you want. So what's the final answer?
4 over.
4 over 4 minus x squared to 3/2. Sure, we'll stop there. So basically, let's see, how many did I give you like that? I only gave you one problem like that on your homework. Break them up, get rid of your negative powers, get a common denominator, put them back together. That's how you do that. I'm going to shorten this a bit. Don't want you to get stuck.
That's all it is.
Just do 4. Don't forget to like and subscribe.